to week 8, programming with C++, week 8 of programming with C++. Now, in today's video, we are going to be looking mainly at namespaces and exceptions. Namespaces and exceptions. So, without wasting much time, let's go right ahead into it. So, what are namespaces? Namespaces are features, so it's a feature that provides a way to group related identifiers and variables and functions and classes. Yes, it's a way to group all these things under a single name, right? So namespace enables you to group related identifiers or functions or classes under a single name. Okay, so that is what a namespace basically does. So here's a real life analogy of namespaces, right? So let's take it that we are in a big school, right? Now you know that in every school has classes, right? Classrooms or classes, yes. So let's take it that we are in a big school with many classes, right? Then in each of these classes there are students, right? Now let's take it that in class one, okay, there are students that have certain first names, or students in class one have their first names being the same as students in class two. Okay, so for instance, I can have a Kofi in class one and a Kofi in class two as well, right? Now, in order to avoid these kind of naming conflicts, meaning when I want to call Kofi, right? In order not to go and call the wrong Kofi, okay, we yes, let me say me, I have to attach the class Kofi is in to Kofi's name so that it's clear, the Kofi that I'm looking for. Okay, so we have Kofi in class one, Kofi in class two. So if I'm looking for Kofi in class one, I won't just say go and call me Kofi, but I'll say go and call me Kofi in class one, or go and call me Kofi from class one. That way it is easier to know the specific Kofi you are going to call. So that's how namespaces work. So they kind of provide this kind of space where you can group related, members under a single name. So this is the basic structure of a namespace, right? You have your namespace and then the name of the namespace. So for instance, namespace school, namespace church, namespace police station. Yes, so you have that, and then your curly braces. Now within these curly braces you have your members, and each member has a data type, right? Or each member should be headed by a data type. So for instance, you can have int, maybe age, string, name. Yes, these are members, right? So name is a member, age is a member with the data type string and int respectively. So that is the structure of a namespace. So let's go ahead to demonstrate that. So I open my code blocks. Now we are talking about creating a namespace, right? And uh, mind you, yes, mind you, namespaces are created in the global scope. They are created in the global scope. Namespaces are created in the global scope. So let's go ahead and do that. So over here, just quickly use this. Since we are creating our own namespace, let me erase this namespace. Now mind you, that namespace you saw there is an inbuilt namespace. We'll get to the types of namespace. So that's just a heads up. Okay, so let's create our own namespace. So the syntax was that we bring our namespace, so namespace, then the name of the namespace, so in this case school, then bring our curly braces, right? So within these curly braces we have our members. So our first member will be dress, sorry, name. Our first member will be name. Our second member will be um let's say house number. Yeah. Second number will be second member will be house number. So since house number is contains numbers, then we use the integer data type. So house number. Then our third member would be let's see our address. So our address, yeah, third member will be our address, and that's it. So in doing so, we've created our personal namespace, right? So this namespace is called school, and then the members of school are the name, the house number, and the address. Name, house number, and address. Okay. Okay, you let this correspond to uh, let me say, okay, instead of using house number, since we are seeing the namespace is called school, I want the members to also match with the name of the namespace. So instead of using house number, let's use school number. Yes, instead of using house number, let's use school number. Yeah. So or ID, anyhow you want to, any way you want to represent it. So we have the members of the school are name, school number, address through their respective data types. So let's go on ahead to accessing namespace members, accessing namespace members, accessing namespace members. Okay, so in order to access the namespace members, you see we've created a namespace already, right? We've created a namespace, that's school. Now we want to access the members. So how can we access the members? The structure is simple. We indicate our namespace name, that is the name of the namespace, then two colons, and then the particular member we are looking for, right? The particular member we are looking for. Now this is done in the the local scope here. This is done accessing namespace members is done in the local scope. So as you can see, here is a typical example, right? Here's the namespace that was created in the global scope. This namespace was called programming, right? And then um, a member called func, right, with the data type void is found within the namespace. So since func is the only member, in calling out or in accessing the namespace members, automatically you would have to write or introduce func because func was the only member, right? So um, your namespace name as the programming, the double colon, and then the member that you want to access. So that's it for accessing new season. So let's try to access the one created over here. So let's come down to our local scope. So in this case, I want to access the member name, right? So I'll go school, then double colon, then name. So I have in this way I have accessed uh, the member name, right? I have accessed the member name. I have accessed the member name in the local scope, right? So that is accessing namespace. You can also access the school number. That will also follow the same syntax, right? School double colon school number. Yeah. So yeah, number. Okay. So this is how we access the namespace members. So let's move on to, let me see. Yeah, let's move on to namespace with using directive. So the Directive tells the compiler that the subsequent code is making use of names in the specified namespace. The directive tells the compiler that the subsequent code is making use of names in the specified namespace. So when we do this, okay, when we say namespace using namespace programming, okay, this is the namespace, like creating a normal namespace. Yes, this creates a normal namespace. Now, namespace with using directive is when we want to use the entire or access the entire namespace. So we say using namespace. Okay, per the explanation. That is what the explanation means, right? So let me highlight the parts. It's making use of names in the specified namespace. Okay, it's making use of names in the specified namespace. So when we see using namespace programming, then we are telling the compiler that we are making use of the names in the entire namespace. We're making use of the names in the entire namespace. So in this case, the names in the entire namespace was function over here. This namespace was function, right? So using namespace programming, if I access or if I write function, I'm telling the compiler that I'm using the entire or the all the names inside the namespace. That is programming. Yes. So that is namespace with using the directive. Namespace with using the directive, and then we have the direct access. You know, namespace. We have the direct access. That one is what we did. This is direct access. Okay, this direct access. The one we did was accessing the entire uh, name or the entire names in the namespace. Yeah, that the one we just discussed. But then this is the direct access when we want to quickly, when we want to be specific. Let me put it out. We want to be very specific. We are specifically accessing one member from the namespace. That is when we use this the name of the namespace, the double colon, then the particular member, and then we have um, we have this one as well. We have this one as well. The using programming double colon func. We have that one as well. So as for that one, this is for using specific items, right? Using specific items. So they're using programming double column func is for using specific items. So in this case, only the func will directly be accessible. Only the func will directly be accessible. That's the func as a member in programming would be the only member accessible to us at that point. That is also for this one. So this one is for using specific items. Then we have the direct access one, and this one is let me see. This one is using the entire namespace. Then the direct access is this one. This one is the direct access. Okay, so let's move on. So we have types of namespaces, right? We have the inbuilt namespaces. So these are basically embedded in the library, the C++ library, right? So they contain most of the built-in functions, objects, and classes. So let's take a look at them, right? So the std namespace is an inbuilt namespace. So the std namespace is the one that allows us to, be able to write the cout cin without attaching std to it. Okay, so in C++, if you don't, you see, in every code you write in C++, okay, for example, I erase the value and bring it back. So I'll say using namespace st namespace st. This very statement I've made here, right, is what we are talking about. So this is the STD namespace, right? So this is an inbuilt namespace. So we are using the entire items in this namespace, right? We are using the entire items in this namespace. In this case, the C out, C in, right? So this enables us to be able to write C out, C in without attaching STD to it. Okay, without attaching STD to it. Okay, so when we do this, it means that we've accessed or we're accessing everything in that namespace, in that STD namespace, right? So if you don't bring this in your code, then it means that whenever you want to see out something, okay, then it means you have to directly access it. That is when you do this. So this is direct accessing, right? I'm directly accessing the see outs before you come and display whatever you want to, display, right? If you don't bring your using namespace std, this is how you would write your C out every time. So you can see, right? Because I didn't indicate that I'm using namespace std, I have to directly access whatever is namespace std, right? So that is C out and something like endline. Okay, so you see this method is very like stressful because every time you'd have to do STD double colon before you do your C out. So just to avoid all those unnecessary, long typing, just access it, access everything right there in the global scope. So using namespace, then you are done. Why do I keep making mistakes? ST, okay, then we are done. So you don't have to go through all that trouble of directly accessing it every time. So that is the STD namespace. So an example is, as you can see, I've already demonstrated it, so I'll skip this. Then inline namespaces. So a namespace where its members are accessible directly without using the namespace name. I have also demonstrated that one. So wait, here where a namespace where its members are accessible directly without using the namespace name. So I'm sorry, an example is what you see here, right? So using namespace std, inline space. So your void display, this is a function, right? Void display is a function, then see out inside inline namespace. So for the inline namespaces, you see the user created this inline namespace over here, right? Now, in order to access the inline namespace the person created, the person just brought display. So inline namespaces give you direct access, or you should directly access, right? Then without using the namespace, okay. So the members are directly accessible without using the namespace. That is what they are trying to say, or that is what I am trying to say. Members are accessible directly without using the namespace name. So once you attach inline to the namespace, that's it. When you're accessing it, you don't have to include the namespace to what you are accessing, right? So that is inline namespace. And now we have anonymous namespaces. So a namespace does not have a name called an anonymous namespace. It ensures that the entities in the unnamed namespace are limited to that file. So there's an example, right? So using namespace std, anonymous namespace, then as you can see, the anonymous namespace doesn't have a name. It is unnamed, right? It's unnamed. So it's just namespace, then the members, right? So accessing an anonymous namespace, you just go straight for it, right? See out the value. That's it. You don't have to mention the name of the namespace because the namespace you created doesn't have a name in the first place. So how would you access the namespace that doesn't have a name? So you just go straight for it and access the members, right? So in this case, see out value. Value was a member in the namespace, the in the anonymous namespace. So that is anonymous namespace. We move on to exception handling. Exception handling. Exception handling. So exception handling is based on keeping the normal functionality of the program separate from error handling. So let's cite an example, right? So imagine you are a pizza delivery driver, okay? So normally you would take the pizza from the shop, drive to the customer's address and deliver the pizza. But sometimes you know this world we are in, nothing goes as planned. So sometimes things can happen. Yeah, things that you don't expect can happen, right? So a customer can give you a wrong address, your scooter or your bike or the one you are using to deliver the pizza can get a problem. Maybe we can face or you can be getting problems with your mode of transportation, and then maybe your pizza can also fall on the way. The pizza that you are going to deliver can also fall on the way. So um exception handling, right? It's like having backup plans for these kind of situations. The situations that are cited. So you are going to deliver pizza. On your way, you faced a flat tire. Maybe your bike you are using, you faced a flat tire. The customer give you a wrong address. So if this should happen to you, then exception handling is like having backup for these situations, right? So what happens if the customer gives me a wrong address? Or maybe I'll call him to verify, right? What happens if I get a flat tire from my bike, right? I will call a backup driver. I'll call a backup driver to deliver the pizza. Okay, so that is how that is a real life analogy of how exception handling works, right? So let's look at the basic structure of exception handling. The basic structure of exception handling, right? So let me quickly demonstrate that over here. So basically, let me see. Uh, let's remove this. So let me also comment this. Okay. So um we can have okay first what first let's look at this before I do that. So see, okay, so try and catch blocks, right? Try and catch blocks. So mind you, there are components of exception handling, right? There are components of exception handling that we need to know, right? So there's a part of the program that will throw exceptions, and then there's a part of the program that will catch the exceptions or the error. It will handle it by catching it, handling it. So that brings us to try and catch blocks. Try and catch blocks. So let me now show you the basic structure, okay, of um exception handling by try and catch blocks is. So the basic structure of try and catch blocks is simple, right? So let's say, okay, let me just stick to the pizza delivery example, right? okay, no, let me use something more easier. Let me use something more easier. So since this is the basic structure, I wouldn't, really give any like scenarios or anything like that. So let's just look at a simple basic structure. Okay, so try. Okay, this is a basic structure of a try and catch block. So we have our try. So within this try, then we can write our code, right? In any statement, you can make any statements here, right? Our normal line of code, maybe you are adding two numbers, you are dividing two numbers, anything at all can be within the try and catch, sorry, the try and block. Yeah, anything at all can be within the try block. So let me just comment that, please. Let's say normal code. Yes, so I've commented that part. So your normal code can be there. Again, this is a basic structure, so I will not use a scenario yet, right? So when I'm you know using an example, and then you understand. But this is a basic structure, so I'm just showing you how it looks like. So the normal code will be here. Okay, then let's go down to where the problem occurs, or if a problem should occur, what would happen. Okay, so after writing your normal code, then you bring in that exception. Okay, so if then the problem, right? So in this case, the problem can be anything at all. Okay, maybe you are dividing two numbers, right? So you know that you can't divide any number by zero apart from zero. So you can divide one by zero, you can divide three by zero. It will give you math error when you use your calculator. It give you a math error. So let's say you are dividing two numbers, right? So the problem here will be if the second number is equal to zero, right? So you can write that in this bracket. Okay, but since this is just the basic structure, I will not do that. So I'll just put problem there. So whatever the problem is, right? I've illustrated what it can be. I've given a scenario. So then you bring your curly braces again. Then if there is that problem, what should be the error message, right? So in this case, this is where the true exception handling comes in. True simply meaning that it will throw the exception, right? If should the problem or should the problem be brought into reality, okay, the true exception handler will throw the exception, right, to the catch. Okay, so over here you just write true, then whatever error message that will be displayed, right? Maybe in this case, okay, let's just use error message, error message. Yeah. So row, then error message, then terminate, right? So what again? Let me illustrate what I'm trying to say. So you first write your try, okay? So within the try, so this is all happening in the try block, mind you. There are two blocks, the try block, the catch block. So this is happening in the try block. So as you can see, the try and then our curly braces. So within the try blocks and curly braces, then we had all this. Okay, so our normal code, then should the problem be available, right? Then we throw the error message, right? Or we throw the exception, we throw the exception, then we move to the catch block, right? Once you throw the exception, we throw it to the catch block, and then the catch block handles the error. The catch block will handle the error. So after throwing the exception, we close a try block. So now we are done with the try block. So now we are done with the try block. Okay, we are done with the try block. So we now move on to the catch block. So for the catch, this is the basic structure as well. Okay, so we have our const and char. Then mind you, this is the basic structure. I'm not making this up. This is how it is. Okay, so let me just write it down for you. Sorry. Yeah. So this line of code I've written over here, right, will now catch the exception that it threw through. It will now catch it, right? So by catching it, it will handle the exception, or to handle the error, right? So that is what the catch will do. So let me also comment that. So let me see, catch error, okay, or catch a exception, right? So let's just stick with the error. Then let's come down. So now see out, then the problem, and the error message will be displayed. Okay, then we close our catch block. So let me explain what I've done here. So after the catch catches the error, right, or the exception, right, we are instructing the console, right? We are um instructing the console to display the error message, right? So again, let's go back to the scenario where we are dividing two numbers. So we know in dividing two numbers, the second number cannot be zero. Okay, unless both numbers are zero, the second number cannot be zero. Because in dividing, you get an error, right? And now dividing the two numbers, and then I have a friend and I have made the second number zero and the first number, let's say, five, right? Definitely, it's an error, right? So I use my try and catch block method to handle this error, right? So I introduce the problem. So if the second number is zero, then throw error message, right? So it will now throw the exception to the catch block. The catch block will display the error message. It will display that there's a problem, there's an error message, right? So that's basically how exception handling using try and catch method or block works, right? So let's look at this quick example, right? So I kept on giving an example where I was saying you are dividing two numbers. Okay, so let's try doing that. Okay, so over here, let's initialize these two numbers. So A and B, right? I try to divide A and B. Okay, then we our A both are integer data types here. Then we accept user inputs, right? So let's say see out, enter two numbers. Then see in. So we now accept user inputs. So the user will enter the his or her two numbers, right? So A and then B, right? Or you can also decide to do C in A, then you terminate it, C in B, then you terminate it. Anyhow you decide to do it, right? Then we come to our try and catch, our try and catch, our try and catch block. Now we know that definitely in dividing two numbers, the second number cannot be zero. I've already said that, right? So since we know there will be an error when the second number is zero, then we use the try and catch block to handle that error, right? So now we come there. So we have our try. Now what is the problem? Let's look at the problem. If b, since b the second number, if b is equal to zero, right? So that will be what will cause an error if b is equal to zero. Then we throw this message, or we throw this exception, right? Cannot be divided by zero. Okay, cannot be divided by zero. Okay, cannot be divided by zero, zero. Okay, so this is the exception, cannot be divided by zero, right? Then we proceed to go to our uh catch, right? But before we go to our catch, should in case the result is different, right? Should in case the there are no problems, yes, should in case there are no problems, right? Definitely we would want to display our correct answer, right? So we do that in the try block. Sorry, we don't do it in within the try block, but we do it like outside the try block. Okay, so it will be between the try block and then the catch block. To be between the try block and the catch block. Or hey, am I seeing it right? Okay, wait, relax. Okay, fine. If we are to show our results, right? Should in case there are no problems, okay, it will still be within the try block. Yes, it will still be within the try block. Okay, so let's instruct the system to display our results. That is, should in case there are no errors, right? And then we want the system to display the actual results. Then we just simply pass out this instruction, right? So a divided by b, sorry, a divided by b. Then we end line, then we end line. A divided by b, then we end line, right? So over here, the problem is if b is equal to zero, then there will be an error. So we told this exception cannot be divided by zero, right? But then in case there is no error, then our result will be displayed, right? Then move on to the catch block. Now in the catch block is going to catch that error message, right? So in this case, let's see. Yeah, that's basically it. Yeah. So the error message is the message. Okay, you to make it clear, let me just use error message. Okay, so error message. Okay, then um our problem, right? Problem. Oh, uh, uh, problem, and then error message again. Right? Message. Okay, so over here. Hey, then we end line. Sorry, then we end line. Let me end line. Okay. Huh. Now we are done. Okay, we are done. So the catch block now catches the error the throw will throw at it. Then it will display the error message, right? So the error message is cannot be divided by zero. So let's see if this code actually works. So the system is instructing me to enter two numbers. So my first number will be 6, my second number will be 0. And let's see what happens, right? So problem cannot be divided by zero. Problem cannot be divided by zero. So this shows that our try and catch exception handling is working. It's working since there is a problem here where the second number is zero. It is showing us that it cannot be divided by zero. The problem cannot be divided by zero. So that is basically how the try and catch works. The try and catch, exception handling. That's how it works. So that is what I have shown you, right? So we have, let's move on to benefits of exception handling. Benefits of exception handling. So um, separation of error handling code from normal code. Separation of error handling code from normal code, and then functions or methods can handle only the exceptions chosen, and then grouping of error types. So these are the benefits of exception handling, right? So it separates error handling code from normal code, and then functions or methods can handle only the exceptions chosen, and then grouping of error types. So that's basically a benefit of exception handling, right? Then let's go on to separate compilation. A function definition is a function declaration in which the body of the function is presented. Okay, we know what function definition is already, right? So let's see. So the function definition, uh, this is basically just talking about function. Let's skip that. We've done functions already. So yeah, this is how a C++ program is run. So it's a step-by-step process, right? First of all, your editor. First of all, your editor, your text editor. So for the videos I have been doing since week one, I've been using code blocks. You can also use Visual Studio Code and other editors. There are other editors for C++ programs. For C++ program. And then your second step is the pre-processing step, right? So over here, that is where the handling of preprocessor directives occur. The preprocessor directives are the lines of code that starts the hashtag. Let me show you. So hashtag include this preprocessor directive, right? So that is the second step. So they basically prepare the code for compilation. They prepare the code for compilation, right? That is the pre-processing, yes. They prepare the code for compilation by handling the preprocessor directives, okay? And then our third step is the compilation or the compiling, right? So the compiler checks the code for syntax errors and then translates it into machine code. So the compiling, the main function here for, for the compiling stage is that its main function of the compiler is that it converts the code, right? The code into machine code. It translates the code into machine code, the C++ code or the high level. C++ is a high level language. So it will convert or translate that high level language, that is the C++, into machine code. Now in the linking process, the linker combines the object with libraries and other resources to create an executable file. And then the loader loads the executable file into main memory for execution. Then the execution is where the program is run. Yeah, where the program is run or basically executed. So that is the entire process. Now we come to header files. So C++ has a variety of header files available for us, right? Now in C++, all the header files may or may not end with .h. So it means that header files have the extension .h, but they may or may not end with the extension .h, right? So header files are basically used to declare an interface of a module or any library, right? So we have the components of header files. So a header file may contain function definition, or they basically contain, okay, they basically contain the function definition, the data type definition, the macros. So the syntax for header files are the hashtag include, then the file name .h. So let me show you an example of header file. Okay, so the IO stream, this IO stream is header file. Okay, IO stream is header file. It's an inbuilt header file. Okay, so the syntax is hashtag include file name .h. And as we said earlier on, or as we gave to see earlier on, not all the file names will have the extension .h. Okay, they may or may not have the extension .h. So the example I showed you, I assume didn't have .h attached, but it's header file. Then let's move on to importing the header files. So to import the header file, you just use the preprocessor directive hashtag include. Now I mentioned what the preprocessor directives do. Okay, they prepare the code for compilation. So you know, importing of header files and all that, we use preprocessor directives. So hashtag include. Then let's move on to the types. So as I mentioned earlier on, we have pre-existing header files or inbuilt header files, and then we have user-defined header files. So for the pre-existing header files, they are the IO stream, the CMAT, the string, the Seno, the vector, right? I'm sure there are more examples, but these are the most common ones that you may be using a lot. And then for the user-defined header files, they are defined by the user and can be imported using the hashtag include, right? So in this case, you will create your own header file, right? So this is the syntax for that. So you can create your own header file by writing a normal code. But in this case, you save instead of saving, you see C++ um, programs are saved with the extension .cpp. So in your text editor, if you create a C++ file, okay, and you write your code, right? The name of the file, okay. After you write the name of your file, that is in saving the file. After you write the name of the file, to add the extension .cpp to the name of the file. You have to add the extension .cpp to the name of the file, and then we have your header file. So in this case, instead of saving the header file, instead of saving the file name with .cpp, you save it with the extension .h, right? So you basically just write a normal code. So in this case, you are creating your own header file. So any kind of header file you want it to be. In this case, this is a function. This is a function. So the sum of two numbers, right? Int a, int b. Then your return is basically the sum of these two these two variables. So you've written down your own C++ code. Now you save this code using the file name extension .h. Okay, then you import this header file by using the preprocessor directive hashtag include, then the file name. Okay, so in this case, the person saved the file as sum with the extension .h. So he has imported this code he wrote as the header file. So he has created his own header file. Okay, so he wrote down this code. So this is the uh, code for his header file, and then he has imported it. So hashtag include sum.h, right? Sum.h. So that's how you create your own, or yeah, that's how you create your own header file. Okay, so you can see he also made use of the header file. So he has demonstrated how he accessed or how he is using his header file. So the sum of two numbers, right, is what he is basically performing. So since A is 13 is B is 22, then the sum. Okay. So since he had already created a header file with the instructions or with the code to execute what he has written here already, you can go straight ahead and then just proceed to add these two numbers, right? Because he will import um the the content from the header file he created. So that is it for user defined header files. So in creating a header file, there are some things that you should avoid. There are things that you should avoid. So you do not define anything at all when you are creating a header file. You don't define data, you don't define functions, you don't define them, you just declare them. Just declare them and then you come and define them later on when you import them. So you don't define functions, you don't define data, and also aggregates. You don't define aggregates as well. You don't define them, and then you don't uh, let your header file contain unnamed namespaces. Your header file cannot contain unnamed namespaces, and then you can't use directives in your header file. So let's move on. So a program is a collection of separately compiled units by a linker. So I think in week one we basically looked at what a program was. Let's do a quick revision here. So a program must contain exactly one function called main, right? So this is basically showing us how a C++ program looks like. Okay, so a basic C++ program must contain exactly one function called main. So that's, let me show you. So int main, this is the main program function, right? Int main, int main. So the main has a data type called int here, but that's basically what it means. So the main computation performed by the program starts with the invocation of the global function main and ends with a return from main. Okay, so as you can see in our program, it starts with main and it's supposed to, okay, let me show you. It's supposed to end with return 0, right? Yeah, return 0, return 0. So start from main, returns, sorry, ends at return, right? Starts from main and ends with a return. So that is the basic syntax for program components, right? So your int main, and then the body. The body will contain everything, all the codes you write. That's where the body, or that's what the body would, code, or that's what the body basically is. The the entire code you work with. Then after you are done, it will end with return. So that's the syntax. So program termination. So a program can be terminated in several ways. So by returning from main, that is what I showed you with the return 0. By calling exit, by calling abort, by throwing an uncut exception, by violating no except, and then by calling quick exits. So that is program termination, and that is also the end of week 8. So we've going to learn about namespaces and exception handling, right? So see you in week 9.